Yeah, it's a hill that I'm willing to die on, that data availability is not a commodity.
Is data availability a commodity? Nick White, the COO of Celestia Labs, thinks not. And today we open up the whole can of worms and talk about the complicated factors of data availability and Celestia as a DA layer. From the security caveats of restaking and slashing to the effects of consensus, validators, and light notes have on it. And then we talk around the perspectives of data availability from an Ethereum-centric versus a more sovereign-centric view. So let's get to it. Let's just dive in. But first, disclosure time. This podcast is not sponsored by Celestia Labs, although I would love them to do so. But Celestia does sponsor my main channel, Go Diego, and we have an ongoing series, Going Modular. It's really good. Highly recommend. The reason why Nick White is first is because I've been thinking on making a podcast. One day I tweet, data availability is a commodity. Nick White says the reasons why it's not, and then says, one day we'll probably chat about it. And I realized we can do that on a podcast. So this is the first episode. Under the disclosure, I hold some TIA, not a lot. I've held some in the past. My wallets are public. Right now I hold close to zero. All-time high position was like $3,000. And also I do have a working relationship with them. So I do motion graphics and editing work on the side for them as well. Anyways, I think that's all the disclosures. I think disclosures are really important. And this slot is dedicated for disclosures if they're needed. I think vague catch-all statements that are disclaimers are often misleading. And in every podcast episode, if you say nothing is your fault, nothing is your advice, and you might hold a position or investment, people don't know the incentives. So, first of all, how many times do you get the VC coded question, like data availability is a commodity, always like in your comments?
That's a really good question. I get it quite a bit, both on Twitter or like when I'm speaking somewhere, like or like if I'm having a private conversation with someone. It feels like this is like kind of the consensus take is like, oh well, data availability is just a commodity, and so for that reason, like the data availability layers are not really interesting for a lot of different reasons. It's like, oh, it's an easy problem to solve. Anyone can just like make their own data availability layer on Amazon S3, or, the price is going to go to zero. So, who cares about it? It's like, and it's not sticky, people are just going to go wherever the data availability is the cheapest. And that really feels like the consensus take. And, it's a hill that I'm willing to die on, that data availability is not a commodity.
Okay, we're going to go into it. Also, do you know like the consensus, like how is it like 100% like most people, or like how can you gauge the consensus on that?
It just feels that I've probably only met, or like most of my conversations are I'm taking that side and the other people are on the other side. I think like for the most part, like when I say consensus, most people are not, they're still kind of exploring the topic, but they would say like their mind is like 80% made up that like, yeah, it's a commodity. But they're still open to like thinking about it. There are a select few people that I really respect who agree with me that it's not a commodity, but it's sort of like I would say like a very small minority of people who would actually argue on my side so far. And, ultimately I think that's a good sign. It's actually very like, it's good, frankly. If people think data availability is a commodity, less people are going to want to try to compete at the data availability layer because they think it's not interesting. And so in some ways, it's actually kind of a good thing that people don't see it that way.
Okay, so now let's go into like, first, what are the ingredients to make DA in the first place? And then like, are those ingredients, do they match like the definition of a commodity? So like, what does it take to create a DA layer? So far on my list, you got like the actual tech and the code. Then you just have validators, and then you have like security and stake. Or do those three fit your ingredients list for a DA layer? Is there anything I'm missing?
This is a good question. I never thought about it from this standpoint. But I think there's a lot more than that, basically. So yes, to produce blocks, right? Yes, you're going to need some kind of software. You're going to need some set of validators. You're going to need, I can't remember the last thing that you said.
Security / stake.
Yeah, like some kind of proof of stake thing. right? Or some kind of like some value at stake. But there's a few other things, right? First of all, you're going to need, first, it depends what is that software and what are the trust assumptions baked into the data availability layer, right? So if it's just a committee of people signing over some commitment to data, that's very different to a protocol that supports something like data availability sampling. Even within the data availability sampling, there's questions of like, is it private DAS? Does it have reconstruction or not? There's a whole spectrum of basically like the security in the protocol itself, right? So that's one thing. Now, of course, that once that protocol is built, it can be forked. Anyone can, fork. You can fork Bitcoin. You can fork Ethereum. All these are all open source software, right? But that's important to when you're comparing between different DA layers that use different software. That is an important thing to consider. The other thing is the validators, but also this aspect of light nodes, right? So maybe light nodes is better to cover later, but in order to support the trust assumptions, the trust minimization of a given protocol, you need to have a minimum set of light nodes that are operating on the network. So that is in addition to validators and distinct from validators.
My question is that like, you talk about the DA specific tech and how like, Celestia and like all these specialized DA layers, they have data availability sampling. But my question is that tech really specific to DA layers? Because can't you get a DAS on like Osmosis or the Cosmos Hub, which are like monolithic app chains? Like, how specific is data availability tech? Because wouldn't it also make sense, like you want your own chain to also have data availability sampling? Would there be flavors of DA layers? Like this is the DeFi DA layer, and this is the NFT one, and this is the Solana aligned DA layer, or stuff like that. Also like Solana could also adopt data availability sampling.
So that's a really good question, and frankly something that has been part of the modular movement, like baked into it, is this idea that in order to have, when you have modular chains, you're going to want to have data availability sampling to enable the block space to scale to support more chains, and you're going to want to have rollups as the way to make the execution layer very easy to verify. So like both of those, like data availability sampling and rollups, that kind of technology, that is key to scaling any blockchain system. And it's actually not unique to modular blockchains at all. So like Solana, in the future, if they want to be verifiable by everyday people without needing a very beefy validator or full node, they would need to adopt data availability sampling and or some kind of like proof, like execution proofs, like ZK proofs or something, or fraud proofs or the equivalent.
My question is that like DAS only scales the bottom half, which is DA, and then like the ZK rollup stuff scales the execution part. But like, couldn't you get like a DAS for like Osmosis, which doesn't have any rollups and doesn't plan to have rollups? Like, wouldn't that also add additional security? Just like, although the execution is still done between the Osmosis validators, like having them also do the 2D erasure encoding scheme stuff for the DA stuff. If that makes sense.
I don't think it wouldn't be that useful unless you have both of them, because let's say like I want to run a full node. I want to be able to verify Osmosis, right? And the blocks are really, really big, right? Without DAS and without some kind of like execution proofs, I need to just download every transaction and execute every transaction and just make sure that, hey, the state that they're all saying is true is actually the valid state. Now, if you only add DAS, then sure, all of a sudden you don't have to worry about the data being available anymore. However, they're still going to have to re-execute every transaction, which means you're going to have to download every transaction anyway. So you're not actually gaining any scalability. It's only when you have both of them that all of a sudden you don't have to download every transaction and you don't have to re-execute every single one, if that makes sense.
Mm-hmm. So the data would be available, but you wouldn't know if it's accurate.
Well, you wouldn't know that. So the end goal is that you want to be able to verify the state of the chain. Just knowing that the data is available doesn't help you at all if you still have to download all those transactions to re-execute them anyway. Now, the reverse does help you scale, where if you did have just execution proofs, but no DAS, you would just have to download all the data still, but you wouldn't have to re-execute it at least. So that would still be helpful. But the ultimate unlock is when you have both together. That's why I tweeted recently, like data availability and rollups are like yin and yang. They're like the two complementary like pieces of scaling essentially.
Okay, so you like must have both of them, and if you only have like, you can't. Okay, that explains a lot. All right, that's good.
Yeah, I kind of want to finish the thought on the commodity aspect, right? So, the other thing that makes it not a commodity is that when you build on a shared data availability layer, you gain special properties of interoperability and access and like shared security with the other rollups, the other chains on that DA layer. And so that's also why, so it's not just the validators, not just the software, it's not just the stake, it's also the ecosystem, the underlying amount of, activity and other applications that you plug into in a privileged basis by sharing that DA layer, as well as the light node thing, which I just talked about, which is that now, so imagine just connecting to the light nodes. And if you imagine the bigger the DA layer gets, the bigger that network effect of all these different applications can be, right? But in order to support a certain size of blocks, a certain amount of DA to support that large of an ecosystem, while still being trust minimized, you have to have a minimum number of light nodes operating on the network. And so those two things are in relation, have like a very strong feedback loop, and you cannot fork those things. Just like if I took Ethereum's software and forked it right now, launched a new Ethereum Nick Ethereum, no one gives a shit. No one's going to build on it for a lot of different reasons. I mean, like there's no other activity. There's no there's no stake security. There's also, but in this case, it's slightly different in that like also the light nodes, I can't like fork all the Celestia light nodes. I can't just have all those people all of a sudden start running my light node software, right? So there's a penetration into the market of the nodes that is actually very significant to enabling the data availability layer to accrue other network effects that make it not a commodity.
Okay, so the code is all open source, but you could take that all day long, but you can't. Is this also where it comes with the idea of like everything at the end of the day is social consensus, and like you can copy the code or like change whatever you want, but like with the case of Bitcoin, you could propose a block, but like if no one else cares about it, then like is it even valid, is it even real? So is that ultimately everything is just like social consensus, and like light nodes, that's the power of them?
I think it's slightly different, it's sort of like, okay, so we're social, like, for example, like, let's say subjective slashing, right? Like let's say I mint an ERC20 token on Ethereum and I give it to, and there's like a community, there's like a, I don't know, decentralized group of people that all say, I ascribe value to this token. It's literally just a meme coin. There's no utility. There's no network effect. Like no one is running a node. Like there's nothing, right? It's just that there's a group of people who have agreed to ascribe value to this coin. That is strictly like a social consensus oriented sort of network effect, if you will, right? And I think the social layer is very important, right? And you could just, and just with social consensus, you could say, okay, we're going to like completely, I'm just going to mint a new coin. Let's all now ascribe zero value to the old one, and here's the new one, right? And now all the value just gets pointed here. I think that I'm trying to think of like how, applying that to a DA layer like Celestia. I mean, the thing is that you'd have to, not only forking the software, that's no problem. You could also fork, I guess, the token value. You couldn't really, unless all the other applications wanted to fork, you couldn't really fork that. Unless all the other light node operators wanted to fork, I don't think you could fork that either. It's like, there are some sort of like, it's like a build out. It's also like the light node is going to be integrated in wallets and explorers and all these different things. And like, yes, if you can get the whole community, I guess, to agree, we're switching here, yes, but I guess like part of the point is that you can't, with social consensus too, you can't, it's not like you can just like copy and paste it and now you have two. There's still going to be one network. It's like, it's more like splitting and dividing, or just like, what I'm trying to say is like, you can't copy paste social consensus, right? You can fork it, but it's still a scarce finite thing. So you can't just say, all right, I'm going to copy and paste your whole protocol and your whole community. That doesn't work, right? The community can fork and split, or fork and point to a new thing. But again, that's different. Like Ethereum forking because of the DAO is different than like Justin Sun saying, I'm launching Tron, and so I'm just going to copy and paste Ethereum. Like the community did not get copy and pasted over, right? And I think there's even more. It's the same with the DA layer, basically, in a lot of ways.
So I think we covered the like technology part of it all. And then I included validators, technology, security, and stake. And then you also said social consensus and the light nodes are important to DA layers.
And the ecosystem of applications.
Now let's talk about the validators. So there's also this constant thing of like, is validator count really, after a certain point, is it really all that valuable to have like, instead of 200 validators, 300 instead of 300, like how much do the actual count, how many validators are in the network? Or I should say, validators matters.
This is a really good topic because there's an overemphasis on the validator count, in my opinion. And like this notion of a Nakamoto coefficient or whatever, and I can't remember how it's derived, but it kind of comes down to a very common misconception, and it's kind of even baked into the word validator, right? Baked into the word validator is validate, like as if, and a lot of people, including myself in an earlier life when I was getting into blockchains, I thought that the security model of blockchains was, you trust the validators, you trust the miners, right? They're meant to uphold the rules of the chain on the rest of the users, the rest of the network, right? I thought that was just baked in, but that's not how blockchains work. And if they did, then they would just be glorified consortium chains, right? Where the consortium members are just the validators. And you can argue that, we'll just make the consortium really, really big, right? Bigger and bigger is better. I agree with that. But ultimately, the issue is that what you want is to be trust minimized, meaning you want to have as low of like trust assumptions as possible. And you achieve that by basically having the participants in the network verify the chain directly. So they don't have to trust. I don't have to trust that the validators, if the validators try to mine an invalid block, ascribe a million Bitcoin to themselves, the other nodes in the network who are not even miners should also reject that block and should not follow it, right? So that's just like an important framing that people get it in their head that like you're not meant to trust the validators to validate the chain. The users and the participants are meant to validate the chain because the validators are not trustworthy. They could cheat, and they have a huge incentive to cheat. They can literally mint an infinite amount of money. They could spend your coins without you even signing. So like, so anyway, validators are just about the function that they perform is to order the blocks. Where do you need a committee in a blockchain? The only place you can, or one of the only places you can, you have to have a committee is in consensus. There's no objective way of reaching consensus without having some set of people who vote this is the next block. Whether they vote by mining, whether they vote via proof of stake, they need to vote on what the next valid block is, and there's no way around that. But they're not voting on, they are voting on the validity in a sense that they are ascribed, like if they vote on an invalid block, you can have it such that they get slashed, but you can't rely on that for the security of your chain.
What do you think would be a better name for validator? Because like validators, they do validates, but also like if you're a ZK rollup, you can also validate these proofs. Or like if you're a full node, you can still validate
Yep.
if these transactions are valid. So do you think like just like gutting out the term because it's kind of convoluted and just going with like proposer or like
I just think of consensus nodes, and actually then like validating nodes are actually what the users should be running. Like I should be validating the chain. If I am using the chain, I should want to know that like everything is all the rules are being followed. So I should be verifying it, like validating the chain. So we call them consensus nodes because that's really their function, is to take in the transactions, order them, and come to consensus on that ordering for everyone else. And now, so like with that in mind, right? Your original question was, so how many is the number of validators that important? Now, where it does become important is that these validators have a special control over the liveness of the chain and the censorship resistance. They also have a special control over MEV, essentially. So they do perform an important role. Now, if you think about, so with those three things, like how important is it to have a higher validator count? Well, with the liveness thing and also with censorship resistance, it's actually not so much about the validator count so much as the stake distribution, right? Because let's say I want to, for the network to go down, 1/3 of the stake needs to go offline, right? So how hard is it to get 1/3 of the stake to go offline and halt the chain? That's the important thing when you're thinking about liveness, right? And that's oftentimes, let's say you have 10,000 validators, oftentimes because of stake centralization and just like power laws, which I think are somewhat inescapable, that number of validators is going to be like 10, even if you have like 10,000 different nodes. Or let's say on Ethereum, right? They have this like home staker thing or whatever. The reality is that even if they have 10,000 nodes, like 30, like, I don't know, 3,000 of them are controlled by like Lido, for example, or like, like it's just really not as decentralized as it looks. It's like all kind of like decentralization theater, essentially. So that's the liveness part. Censorship resistance is also the same, which is like if let's say, well, unless you have multiple concurrent proposers, right? The ability for someone to censor your transactions depends on like how much stake can they control to censor you. Because let's say they control 90% of the stake, then every time there's a new block that gets proposed, they have a 90% chance of censoring you, essentially. And so then now that kind of gives you a time bound, like it's kind of like an exponential sort of probability like decay of like how long they can censor you for, right? And so that, again, it comes down to stake weight, not necessarily the number of different validators. And then the last one, which is like MEV, is also, it's not really something that I don't like. Obviously, I think there's sure like having more validators, and for example, even like multiple concurrent proposers, so that someone doesn't have a monopoly over the ordering in a single block, can be helpful. But again, I don't think it's like increasing the validator count beyond a certain amount matters. I think there's going to be lots of other in protocol ways of addressing MEV, and making it more fair. And honestly, some people don't think MEV is necessarily bad. Maybe MEV should get captured and allocated to some kind of purpose within a given chain. So ultimately, yeah, I guess what I'm trying to say is like stake weight is more important than validator count. Now, obviously, when stake weight gets distributed enough, then increasing the validator count does help, right? Like let's say the stake weight is distributed evenly among 100 validators, and you could continue to distribute it even more evenly, and let's say you double the validator count. Yeah, you do improve marginally on the number of people that it takes to halt the network or to censor you. So it does help, but I don't think, like if you look at most networks today, that's actually not the most urgent thing to fix. It's more about the stake weight. That's the most urgent thing to fix.
Another can of worms I want to get into is like if you described it as consensus participants, right? Or consensus nodes. If they don't really determine validity, then like does security really matter all that much then? And there's like this new argument of like, should Solana even like start slashing because, well, slashing isn't real, or like that whole argument. So what do you think about that exactly?
Yeah, well, so they do now when validators vote on a block, right? They do in some chains, they are voting that like, okay, the state here is valid. Like I'm attesting to this. And so if they attest to an invalid state, they will get slashed. So they are voting and they are contributing a certain amount of crypto economic security to that state that they signed, like the state commitment, right? And so that is helpful. But the problem with that is that the that level of crypto economic security is never enough to be secure against the kind of attacks that you can do with the dishonest majority, which is literally unbounded, that you could just like print as much money as you want, spend other people's money. Like there's no bound to the value of that attack. So that's why crypto economic security for validity to me is not sufficient. Unfortunately, with reorg attacks, that's the best you can do. For a reorg, you can only, because you need a committee, you only can have a crypto economic sort of like settlement guarantee that this block is not going to be reverted once it's been like finalized. And unfortunately, like that's just, but that's fine because a reorg, again, all you can do is like execute some kind of double spend. You can't execute like a full on just like mint infinite funds. Oh, I'm going to steal your funds kind of attack. So like ultimately like being limited to crypto economic security for a reorg attack is not that bad in my opinion. And it's frankly, well, so far it's like the best that we can do. I'm trying to remember your original question.
I think my original question was like, this is stake like a meme? Do you even need slashing if you can just if validity doesn't really matter? Do you even need to enable slashing? Or if validators, aka committee consensus committees, don't really do validity, then like, do you even need slashing? I'm pretty sure you answered that. So
no, not really. Well, yeah, let me go into that a little bit more. I mean, I think it is really important to have slashing. Now, the thing is that people assume that means you have to have the slashing automated in the protocol, such that, okay, there's a reorg attack. Okay, the chain is going to automatically, the honest validators are going to detect that, slash the other validators, and then continue on with the chain. There are advantages to that because then you don't necessarily have to halt, maybe. Although, for like Tendermint, I think pretty much universally, if you have a dishonest majority, you're going to have to halt the chain. Although maybe not, I guess not with like Ethereum and certain liveness favoring protocols. That chain will just like fork off, and these other people will start to like beat those people. But I think the reality is you're probably going to want to halt the chain, or what you'd have to do is you're going to have to revert to some form of social consensus. And what's really important in that scenario is that you need to be able to have attributability to the people who misbehaved, right? So if someone did a double spend or signed an invalid block to steal money in some way, you want to be able to know who those people were so that you can slash them. Because otherwise, if you don't know who they were, there's no way to recover, right? And this is actually one of the problems with proof of work, is that if someone got a dishonest majority of the mining power and they started to fuck with the chain, you're not going to be able to, you can't fork the stake more or less because it's hardware. You could say, hey, we're switching to a different mining algorithm, but then you're essentially setting everyone to zero, right? Everyone's stake down to zero. And so you have to bootstrap your security all over again. You're just going to like now there's a whole new set of like miners or validators. The unique thing about proof of stake that I think makes it superior to proof of work is that even if someone gains a dishonest like majority proportion of the stake or the mining power, whatever, however you want to define it, you can, if it's attributable, when they misbehave, you know exactly who it is, and you can selectively slash those people, and the remaining honest people continue with their stake, and the network can live on. So I think that having automated slashing within a protocol is not as important necessarily, or maybe it could be undesirable because you could have like bugs or slash someone who's actually, I don't know, they had some malfunction with their validator and they actually didn't do anything bad. And now you slash them for no reason. Or like, yeah, like for example, with Ethereum, they had that bug where I can't remember which client it was, basically had a bug and then stopped like signing blocks, and they were very close to getting slashed for inactivity essentially, but it wasn't, no one actually did anything wrong. It was a client side bug.
It was Nethermind who spammed other clients and then DDoSed them, and then they they were like about to be inactive against Slash. So it was actually it was actually someone else that made other. The bug was inside another client, but the clients that were without bugs were the ones who were about to get slashed. So I think that was also funny. That also brings in the idea of like, with security and stake, can Celestia use like restaking, like eigenlayer? I know there's this you guys call it. You guys don't want to call it snacks. What is the actual name of it again?
ZK accounts.
ZK accounts. Yeah. So couldn't you also do some restaking with that, or no?
We definitely could. Before we get into that, I just want to quickly just wrap up on the slashing thing, which is like a while ago and I think a lot of people were kind of like going after Avalanche for not having slashing. And it wasn't about the fact that, and their whole thing was like, oh, well, you shouldn't have automated slashing in the protocol. That's bad. That's actually a fair position, as you can tell, because there could be bugs like this. However, the problem with Avalanche is not that they didn't have programmatic slashing. It's that they don't have attributability, because the way their consensus works is a distributed voting sampling thing. If someone, helps to form like the wrong sort of consensus, you don't even know who those people were, because there's not like people don't sign over one single block, right? So anyway, that I just want to close the loop on that. In terms of the restaking thing, maybe it would be helpful to talk a bit about this idea of the ZK accounts really quickly. So I don't know how much the audience is familiar with Celestia, but essentially Celestia is just a pure data availability layer. So it has almost no execution capability beyond the bare minimum features, which are staking, being able to send and receive TIA tokens on the layer 1, and the ability to, for example, like pay for transaction fees for posting data. Those are the only functions. That's the only kind of state and execution that happens on Celestia. Unlike, for example, Ethereum or Solana, where you have a full smart contract VM, or even Bitcoin, where you have like a more expressive script. So that's on purpose, because we believe that the ultimate layer 1, the ultimate data availability layer, is going to have minimal execution and minimal state, because all that execution and state adds to the overhead of every rollup that builds on top of it. Because every rollup that builds on top of the layer 1 DA layer has to verify and validate the L1 in addition to its own rollup. So keeping that as minimal as possible is very advantageous in the long run. And it also, frankly, has a lot of other downstream effects, like, there's less, the scope of the layer 1 is so limited that there's less to argue about. And there's less governance, there's nothing that you have to change or upgrade. We want the layer 1 to be, frankly, very like ossified from the perspective of like its function. It won't be ossified. It'll always be growing and adapting to be a better DA layer, but it's not going to have to worry about adding other features or like changing the execution model or all these things. Now, the issue with that is that it has a very critical drawback, which is that if you don't have execution on the layer one, there's very limited, that limits the kinds of things that you can do with the native asset. So for example, we cannot have a direct bridge to a rollup in a trust minimized way. The rollup can verify the bridge from TIA up, but Celestia as the layer one has no way to verify the state of the rollup when you're trying to bridge funds back. So that basically makes it so right now we actually just earlier this week we launched the first sovereign rollup on Celestia called Forma, and there's actually a way to bridge TIA to Forma to mint NFTs and things like that. And it's very smooth, but it can't go from Celestia directly to the rollup. It has to go through Stride and Hyperlane up to the rollup. So you kind of need, you're going to need like an intermediary chain to facilitate that. And so that's undesirable because like ultimately you want the Celestia token to be able to be a first class citizen of those rollups and be as like close to the native asset as possible. And so with that in mind, we had this idea Mustafa posted, I think about a year ago on the forum. It's an excellent post. I encourage people to read it. It's called Enabling Escape Functionality, or like functional escape velocity for Celestia via ZK accounts, something like that. Essentially, the idea is that we can actually build a feature into Celestia that achieves the goals of staying state and execution minimized while enabling really interesting things around the native asset, such as trust minimized bridging with rollups. Also, and that was like the main motivation, but also like you can build things like liquid staking protocols, you can build things like restaking protocols, you can build privacy functionality. There's a lot of things you can build with it. And essentially the way that it works is that, a standard account has a private key, right? You have a private key that signs over the transaction and gets verified against the public key to say this transaction is valid, therefore the L1 is going to, perform the action that this transaction is requesting. So I'm going to stake this much TIA to this, validator, or I'm going to send this TIA to this account, something to that effect. What now, instead of having the signature be the proof that the transaction is valid and should be executed, you can make it so that a ZK proof is the proof, like the equivalent of the signature for an account that is a special kind of account called a ZK account, which is associated with a specific ZK program that has certain logic in it, like something to do with verifying the state of a bridge and verifying that indeed this amount of TIA is trying to be bridged back to the Celestia base layer and should be credited to this account on Celestia. Or, this something is happening on this liquid staking protocol, and it's telling the account that controls all the TIA in that staking protocol to delegate to Y validator, right? So all of a sudden you can start to have really rich functionality that interacts with TIA in a native way, and was going to enable a lot of really cool things like restaking, which is I think why you brought this up.
So the ZK accounts eliminate the need for contracts to be on the L1 Celestia chain, and then also the actual keys and the private keys. So now,
well, you're still gonna have accounts with private keys and all that, but yes, it's basically like you can have smart contract like functionality without any VM and without any execution. The only execution that's happening is the verification of that execution, but none of it's happening on chain.
Yeah, that is so cool. Also, now that with that you can get restaking features, there's like this argument over like alignment, or like if you want to be closer to Ethereum, use EigenDA. If you like Cosmos and Sovereign stuff, then go to like Celestia. If Celestia can also use sort of like Eigen restaked ETH, Where does that put all the other DA layers at?
Yeah, so this is another really good topic, which is that, so you know how we talked about attributability earlier? There are certain kinds of faults that are not attributable. And it just so happens that data withholding is an unattributable fault. So what that means is there's actually no way, if data withholding happens, there's no objective way to prove to someone who did it. Unlike equivocation, like double signing and reorgs and things like that at the consensus layer, there's always within proof of stake, you can always know, well, I can see that this guy signed here and he signed here, so therefore he's the common denominator, we got to slash him. In data withholding, you're not able to do that because data withholding is like data availability is a subjective thing. I can't know whether you're withholding data from me or if I'm having some kind of network issue or whatever. It's just that all I know is that I tried to sample your data. I tried to download it and it wasn't there. And so what this means is how this relates to EigenDA is that, well, the only way to slash for something that's unattributable and like not objectively provable is you have to socially slash. So you basically just have to like, hey, all the people who are running nodes on Celestia, you guys all observed that the data was not available on this block. And yet all these validators signed on the block. So it's clear to us that this, like, it's not just me, like everyone else has observed this. Okay, let's talk about it. We're going to slash all those guys and start the network over again. But you notice that there's no way to do that in the protocol. There's no way for me to prove, for example, on chain that these guys are bad. So how that relates to EigenDA is that you cannot use Ethereum to secure an external DA layer or committee because you can never prove to Ethereum, hey, you should slash these folks who restaked the ETH. So unfortunately for EigenDA, any restaked Ethereum ETH does not actually contribute to the underlying security of the DA layer. This is partly maybe why it was kind of obvious to a lot of us that they would have to introduce some kind of token like Eigen to perform that. Now, there are certain restaking applications like, well, I guess, the oracles are also the same. There's no way objectively of proving on chain that like, this oracle, these people lied or not. With consensus though, if you wanted to run an external consensus layer that uses restaked ETH, that is viable because again, there can be a contract on Ethereum where you presented the evidence saying, hey, look, here's the people who restaked on this chain. These guys signed 2 conflicting blocks. I can prove to you cryptographically that's the case. Now slash them, right? But with DA, you can't do that. So ultimately, yeah, unfortunately, I don't see. First of all, I don't really believe in the idea of like, I guess like, yeah, a restaked application is more aligned with the underlying community because it uses the underlying asset. Restaked protocols don't actually derive any shared security from the underlying layer. Like there's nothing about running, I could use any collateral to run my restaking protocol. Like let's say I'm using USDC as my collateral on ETH. I'm not inheriting any security from the ETH L1. So there's no notion of shared security to begin with. But even with that, even the alignment aspect of EigenDA to me is quite a stretch because you're not actually. It's just a Eigen secured data availability protocol. And frankly, another thing I'll just mention quickly is that the ideas behind Celestia actually emerged originally from the Ethereum research forums. So the original data availability sampling paper, Mustafa co-authored with Vitalik, and his original like forum post proposal around the idea of lazy ledger, which is now Celestia, was posted in the ETH research channel. And there was a large effort that Mustafa and John Adler put into trying to figure out how can you actually prove data availability on chain, right? In an Ethereum contract. Because if we could do that, then Celestia or Lazy Ledger wouldn't have to be an external protocol. I mean, it could be external, but it could just be rooted in Ethereum, right? And just be native to Ethereum. But it turned out that that's just not, it's not possible because, as I said, data withholding is unattributable. That then created the need to basically create a new layer one with its own social consensus and its own native token that you could socially slash. And that's sort of where like Celestia came from. So like EigenDA as this like ETH-aligned thing is ultimately just, it's like the same thing, except we can talk more about it, but like the technology behind it doesn't have data availability sampling. It's basically kind of like a committee architecture where you have a bunch of people voting on, is the data available, which is not ultimately, I mean, yeah, it means that you can make it more scalable, but ultimately you're providing the scalability at very high cost of the underlying security and trust assumptions.
And so the unequivocation is why Eigen has the universal intersubjective, what was it?
Yes.
That's the whole reason.
Universal intersubjective work token or something like that. Yeah.
Okay. And so my thing is that like, so if you were to have two DA layers, or, EigenDA and Celestia, let's just make them fight. Would more stake doesn't necessarily mean more security because of this unequivocation, which then means you need this intersubjective work token to then determine the this equivocation, which then means then the security would be reliant upon that token and not necessarily the amount of restaked ETH. Is that correct?
Exactly. Yeah. What I'm saying is that the staking does matter for data availability because it does contribute economic security, but you cannot contribute the restaked ETH cannot contribute any economic security to an external DA protocol because you cannot socially slash the ETH based on the social consensus of an external protocol, whether that's EigenDA or Celestia. So only, for example, the Eigen token, which is, subject to the, and even the Eigen token, by the way, is not necessarily subject to the EigenDA social consensus, but like the broader Eigen, whatever all the other restaked protocols are. And I haven't read the white paper to really fully understand how they deal with that, because to me, it's much cleaner to have like, okay, this token is to secure this protocol. This is like the social consensus around this protocol and when we're going to slash it. If you have that overloaded with a bunch of different services or protocols, it kind of becomes less clear about like, oh, well, do I have to talk to everyone else and agree to slash? Anyway, we're getting a little sidetracked. But yeah, the point is that the restaked ETH contributes 0 to the economic security. Now, I want to clarify something, which is that ultimately you don't want your data availability to rely on economic security because it is inherent to the validity of the underlying system, right? And the security. So unfortunately, in the case of, for example, Celestia being used as off-chain DA for Ethereum L2s, basically where they have a bridge from the rollup or the L2 to Ethereum. If Celestia is being used as off-chain DA, ultimately you're making an honest majority assumption. That bridge has to make an honest majority assumption on the Celestia validators. So there's only economic security. That is the security model. So from that perspective, actually, for example, EigenDA being a committee, if it's only being used for ETH off-chain DA, adding data availability sampling doesn't necessarily help from the bridge perspective. However, it does help. Where it becomes important is that even for the people to be able to socially slash for the data withholding, which is where the economic security comes from, it's much better if there's an easy way for people to verify the DA so that they can actually socially verify and then agree to socially slash. So there is, I wouldn't say that DAS doesn't contribute to the economic security. It does, but it's less, it's not the full amount that it does when you're using a native DA layer, if that makes sense.
And so do you think Celestia will ever use restaking?
I think so. I know that there are teams that are actively exploring and building restaking protocols that will use TIA. And there's nothing that we can, Celestia is a permissionless thing. There's nothing we can do to stop that. And I think ultimately restaking is a tool that developers should have and should be able to tap into. And so I think it's going to be, it's a good thing that people build these kind of things. And I could see that being useful, for example, for, let's say you want to spin up a sequencer for your rollup, or a decentralized sequencer set, or a shared sequencer, and you want to collateralize that with some token. You don't want to have to issue your own token, or you want to somehow, I think the other interesting things about like restaking are when you can have an overlap between the validator sets between two different chains that could allow you to do interesting, interesting, like sort of like, I guess, like extra hooks or like functionality on top of that's not really embedded in the core protocol, but is like adjacent and has some level of guarantees. That stuff is kind of interesting. So I think that should be enabled for sure. And I'll be excited to see what people build with it. Another thing you could do, for example, is use restaked TIA to have like some kind of economic security for a bridge. I think that's an interesting use case. Because bridging between rollups, if they're optimistic rollups or even in ZK, there could be a delay. You can have a higher, sort of like economic bandwidth in the short, near term, like for faster interoperability by having like a bridge that's collateralized with some kind of like stake. So those are some of the use cases I could see working. I don't think ultimately though, my honest opinion on restaking in the long term is that the number of applications for it are relatively small, and will slowly like go down over time essentially, because as like, for example, let's take the bridging use case. I think long term, as interoperability gets really strong and really secure, you have things that are like intent based bridging solutions where the solvers themselves are fronting the money and basically market making this interoperability. I guess maybe the economic security could add some like capital efficiency or reduce the risk in some way for those solvers, but ultimately they're going to be incentivized to just like verify what's happening on chain and own and like take the risk themselves. So like, I don't see that I see that use case as being relatively short term. The consensus stuff could be interesting, but like, I wonder, how many different sequencers do you need? Maybe there's going to be more and more based rollups. Maybe there's going to be, a handful of shared sequencers that do most of the sequencing. So like, how many of these like new how much collateral do you need for all these like types of consensus protocols is relatively unclear to me. I think oracles is an interesting one, but again, like where I'm confused is like, well, oracles are again like an unattributable thing. So how do you make it so that you slash for like oracle misbehavior? It seems like to me kind of like an unsolvable problem to begin with. So yeah, like long term, and also like now let's say you just wanted to have like economic security behind your roll up or some like chain that you want to launch. The reality is that in almost every dimension, if the chain is verifiable objectively, which is kind of what you need to begin with to be able to slash any restaking protocol, right? Then that chain could also just, if it's verifiable, then it could just be a rollup. And a rollup can inherit the full consensus security and DA security of the underlying chain without having to pay for like additional collateral. So I guess though, like maybe you want to have you want to have fast confirmation time, so you have a single sequencer that has some amount of restaked TIA and it just like it gives receipts, and that like, okay, well, when I get this receipt, there's at least like, I don't know, $1 million of security behind it. But I don't know how, like, is that really that exciting? And like how much yield, like you also have to think about the cost. So like how much you have to pay. Like restaking is also just frankly economically not the most efficient thing. You're going to have to pay the cost of capital. Yes, you can share the cost of capital among a lot of people because you're kind of rehypothecating the same capital, but I just don't know if that like brings it down enough to be meaningful for people to absorb, to actually make it attractive to absorb like the risk associated with it. So Anyway, that's just kind of like my rambling thoughts about about restaking. I do think I'm excited to see it get explored, because I could be totally wrong, and like maybe there are some really crazy killer use cases. And I'm of course, I'm wearing my shirt says build whatever, and I think that developers and people building in the space should have as many tools in the toolbox as possible, because that's how you build the best applications. Like the more optionality, the better. So I think restaking is a viable tool that people should use, and maybe there's some really cool things that people build with it.
Restaking with TIA, the ticker symbol TIA, that's sort of unstoppable, and there's probably going to be an ecosystem of like sequencers that use restake TIA to sequence sovereign rollups. But like Celestia itself, do you think it will ever use restaked ETH from EigenLayer or anything like that, or do you think that's more far out or up for the community to decide? What do you think about TIA using EigenLayer or restaked ETH?
Yeah, well, the thing is that it won't contribute to the security of the Celestia DA, right? Because there's no, again, Celestia is just like Eigen DA is an external DA protocol, and so restaking that ETH on Celestia doesn't contribute anything in terms of economic security. So I don't see a purpose for it, other than maybe like vibes and alignment, which I think frankly is part of like the whole reason for restaking to exist, is like alignment and vibes and stuff like that. So, I mean, maybe if like that was a priority, but I think like ultimately we care more about like the real meat and potatoes of this whole thing. And like, that just sounds unnecessary and maybe even a little bit misleading to people, frankly. So overall, I don't see that happening. Something that's actually interesting that I've thought about is like the reverse of, let's say you want to have a bridge, a DA bridge to Ethereum, a DA bridge from Celestia to Ethereum that is maybe more secure than just trusting the Celestia validators. You could have people running like, you could have a committee that runs Celestia light nodes and votes separately, and only that bridge only trusts the DA, the DA the DA bridge that's been relayed, like the data has been relayed to the bridge, if both the light node committee and the Celestia validators have signed off on it. And that way, maybe you can have actually like slightly better security properties than just Celestia on its own. I don't know if like restaking is a necessary part of that. It could just be like an additional multi-sig of like people who you trust, to run those light nodes, and like those people are directly verifying the data is available on Celestia. That's just like maybe one interesting thing that I could see in terms of like bridging between Ethereum and Celestia more intimately.
So to wrap this up, is DA a commodity? DA isn't a commodity because there's no way for light nodes and the social consensus to ever get forked or taken away, or forked or copied, I guess.
So when I was having this conversation about like DA being a commodity or not on Twitter, someone I really respect is also on the Celestia Labs team. His name is Colluding Node on Twitter. He replied to one of my tweets saying, DA, when used sort of as external DA, might be more of a commodity than DA that is used in a native way. And I found that very interesting because, and I'm still frankly digesting that and thinking it over, and I haven't come up with like a strong conclusion, but I think there's some element of truth to that, which is like, if, how we talked about external DA layers, the best they can be is just committees with respect to wherever like the bridge, like on Ethereum, for example, EigenDA and Celestia both look like committees more or less from this perspective of Ethereum. And there's no way to get around that essentially. And so from that perspective, it is significantly easier in some ways to spin up a new DA committee, right? And so the external DA could be considered potentially more of a commodity. But like the native DA, there's actually like, you can have true trust minimization, and the interoperability aspect between all these applications is really important. And the interesting thing is, if you think about rollups in general and L2s, where we have we tend to think like, okay, well, they're settling to Ethereum, therefore they're an Ethereum L2, right? But ultimately, the settlement layer doesn't contribute at all to the security of the rollup, right? What actually contributes to the security of the rollup is the data availability, I guess actually the consensus part, which maybe in some of these things they aren't inheriting the consensus from Ethereum by using Ethereum as a settlement layer, and the execution proofs. Those are the things that actually secure that rollup. The settlement layer does secure the bridge, right? And the security of the bridge is sort of dependent on which settlement layer is located on. But like the actual security of the rollup, to me, is actually more tightly tied to the underlying DA layer. And so when you think about these different L2s, like they're like, you might call them an Ethereum L2 or a Bitcoin L2 or whatever, but like they are, from the perspective of Celestia, all Celestia rollups in a sense. It's like all depends on the way that where you're viewing these from, and like, which thing matters to you more. It's like, well, I'm an Ethereum user, and therefore, and I bridged all these funds from Ethereum to this L2, then yeah, it's true. What matters to you, and this is, L2 Beat does a really great job at this, and they take currently at least, a very Ethereum centric approach to evaluating the security of a rollup or a DA layer, right? And that's because from the Ethereum model, all of these L2s and rollups are extensions of Ethereum. And they're about, and they take the perspective of, I'm an Ethereum user, I have like 10 ETH on Ethereum, and I'm going to bridge it up to these rollups to do some other stuff. But ultimately, I care about the assets down here. But if you take a more sovereign view of these rollups, these L2s as their own chains, and if you're actually just a user of the native assets on that chain, that bridge does not matter anymore, basically. It's like, who cares, right? Then what matters is, well, the data availability, where's that going, right? And how am I making sure that my own chain, the native assets in this chain, don't get rugged? And that's all the things that I just talked about, which is like, where's the data availability happening? Where's the consensus happening? Where's how are the execution proofs being managed? So I guess to loop it back to the commodity thing, I think that, if you're doing off-chain DA, maybe it is slightly more of a commodity, but like in the long term, that's not an interesting, more and more, like increasingly rollups will become more and more sovereign and think of themselves less and less as extensions of some other ecosystem and more as their own ecosystems in their own right, with their own set of users, their own set of assets. And in that world, there is no such thing as off-chain DA, basically, right? There's off-chain DA from if you're bridging to a different trust zone. And that's also, so another thing really quickly about DA related to this privileged interoperability between rollups, if you share a DA layer with another rollup, you can bridge in a trust minimized, very secure way. But if you're bridging to another chain that is external to that DA zone, inherently you're going to have to make an honest majority assumption, and vice versa. And so more and more chains think of themselves as sovereign, they're going to be more and more like the bridging to external things is going to be less important than like the bridging. And they're going to want to bridge basically with other rollups in their shared data availability security zone. And so that world, again, as more and more chains kind of like converge on specific like security zones, that those security zones stop being like, they're no longer a commodity. They accrue these network effects around, the activity, the applications, liquidity, the users, all the things that, we think of a monolithic L1 accruing network effects around, like an Ethereum or a Solana L1. It's the exact same thing on the DA layer, except it's just one layer of abstraction deeper. So rather than being at the application and execution layer, it's that is accruing at the data availability security layer itself.
So you think that right now, like the state of rollups is more Ethereum centric. And so like anything that's not Ethereum is like off chain DA. And so like as we like zoom out, there's going to be DA, there's going to be rollups which don't associate with any sort of DA and they're more sovereign. And so when it comes to like shopping for rollups, what do you think the tiers are? Because there's also people who are bigger than Ethereum called Bitcoin maxis who like see Ethereum as the off-chain chain. And so like from a spectrum of DA, I guess there's now tiers like Bitcoin, Ethereum, then like off-chain DA layers like Celestia, Eigen, Avail, and then like AWS. You think that's a good way to think about it?
Yeah, to clarify what I meant is that so the Celestia view of what a rollup is a sovereign chain, or that they can choose to be sovereign. And I think increasingly more and more rollups will be sovereign. Whereas in the Ethereum worldview, rollups are about extending some like the social layer or basically the community of the underlying L1, which is the Ethereum L1. So the rollups are, and that from that perspective, when you view things in that way, you think of things like the world looks very different. And when you look through the lens of like the Celestia philosophy, the world looks very different. And I think increasingly, a lot of the development around rollups has happened within the Ethereum ecosystem up like to date. And I think that's rapidly changing. There's an increasingly growing like native modular ecosystem of people who just thought about this stuff from first principles without the baggage of like, oh, we need to be, part of like this, we need to scale Ethereum. It's just like, oh, we just want to build blockchains. We want to build sovereign new chains from scratch. And as that mind shift starts to happen, it will become less and less about like, where like the DA layer that you choose is sort of like the L1, I guess, that you're plugging into. So like you wouldn't, if I'm an L2 that has a bridge to Ethereum, right, and I settle to Ethereum, but I post my data to Celestia, you're still within the Celestia zone of security, right? So it becomes like, so you're no longer thinking about like, oh, I'm using alt DA or whatever. It's like, well, Celestia is my DA layer, and that is my zone of security in a sense. And so that's the way that I see, like, so what I'm saying is not that it doesn't matter anymore where you like what you use for DA. Kind of the opposite actually is that like rather than like thinking about where you settle and thinking that that's an important decision, you're going to think more about the more important decision is like, well, where am I posting my data?
Okay, I think that's a nice wrap up. Is there anything else we wanted to talk about? I have additional questions on like, is DA, can you tune the DA period and be like, I only want my data available for 1 week, so can I pay like a little bit less? Or if I want it for longer, can I pay a little bit more? Do you think there's going to be more DA customizations or periods, anything like that?
That's a good topic, and I think something that's worth touching on briefly. Is a lot of people think of DA as like the equivalent of data storage, right? And they're just totally different things. So DA is more like a news network or like a newspaper where you're taking the most important, timely, valuable information and disseminating it across the network as fast as you can so that everyone can see it. And at least know, even if they don't read all the information, they don't read the whole newspaper, they can see the headlines and they can verify that the newspaper was published and seen by enough people. So that's the role of a DA layer, is about like dissemination of information. And that's really important for the security of all these chains that are building on top of it. So it's all about the real time, newest stuff, the new blocks that get mined, the new transactions that have been published that everyone should be aware of. Data storage is completely different, which is about, okay, I have some data that I want to make sure I can retrieve later on. I want you to store it. It's more like a library. It's like I'm going to give you this book or this newspaper, And I want you to give me a guarantee that in 50 years when I come back, and it's no longer going to be relevant. No one's going to give a shit about that. Like in terms of the security, it's not going to, like all the stuff, all the security related things relating to that information have passed, right? It's like, we're not going to reorg, go all the way back 50 years and say, oh my God, you know what? This transaction was invalid. Let's start over, right? So you want to make sure that data is retrievable. And the reason that's important for rollups is so that you have a liveness guarantee, which is that if you needed to regenerate the entire state of the rollup from Genesis, you can. And that is a different assumption than the validity, which is what DA is about, but also, frankly, is something that has much weaker trust assumptions. You just need one copy of it to exist somewhere with someone who's willing to serve it to you. And so it's not really something that I think people overweight that in their mind. Now, in terms of data availability is not really there's not really like a time limit or I want to make sure my data is available for 21 days. Like data availability is a yes or no thing. It's like, I know, okay, I sampled that block. I know the data is available. It's not like, oh, hey, I want you to make my data available for 21 days. And after that, I don't care. It's like, no, I want you to make my data available, meaning you published it. And now it's out there and everyone's seen it and verified that it exists. That's a binary thing. That's not something that now storage is something that you can set something. It's like, I want you to make sure that I can retrieve this for 50 years. After that, you can discard it. I don't care. That's true. So that's the way to think about it. Related to that, not to confuse people, but there is pruning on Celestia, meaning that if you want to sample data that's older than 21 days, or you want to download data that's 21 days or more, since the most recent block, you have to go to special archive nodes. So the Celestia full nodes are not going to be expected to keep that data forever, because just like a newspaper doesn't keep every copy of the newspaper in perpetuity in circulation, neither will the Celestia network. It's like, okay, well, that newspaper, was published 21 days ago. It's no longer in print. It still exists. It's all over the world. People have it everywhere. But if you came to us and you said, hey, can you send me, I don't know, January 1st, 2024 newspaper that day? It's like, well, sorry, but it's out of print. It exists. You can go find it, go to the library, go to your neighbor. Maybe he has it in his garage, but we're not going to store it, if that makes sense.
Okay. So the pruning, the 21 days isn't anything to do with the DA period or DA at all. It's just the performance of the Celestia chain and not keeping everything.
Yeah. So if you have in the future, if we had gigabyte blocks, right, we're adding a gigabyte every 12 seconds. The amount of data that the full nodes are going to have to store is going to be really, really big. Especially if that only adds, it only accretes, right? So then all of a sudden it's just it only gets bigger and bigger and bigger, and they're just going to keep having to upgrade to have, more disk space, right? So we don't want that to happen. So what we instead do is we're going to set a window beyond which those nodes can just prune that data, and that way they can have a constant, much smaller amount of disk space requirement. And again, data availability is binary. It was either published or not published. And so it's not about that doesn't mean just because the data gets pruned that it's no longer available. It was made available. People sampled it. It was published to the network. And you could still, frankly, sample those old blocks. It just might be a little bit slower to sample them because all the full nodes don't hold them. It'll have to go to the people who are holding that data.
Okay, that was a good misconception that I personally had. Also, with gigabyte block sizes, do you think with such scale that we would agree that instead of 21 pruning days, let's bring it down to 14? Do you think that's a possibility?
Yeah, I think you can kind of set that or to whatever you want. Although I do think there's something to do with, so for Celestia, because data availability is part of the validity rules of the chain, it needs to be at least as long, the data the pruning window needs to be longer, or at least as long as the subjectivity window, which I think is also 21 days. Meaning subjectivity window is like, beyond a certain point. I think there's like checkpoints in Tendermint where it's like, okay, we agree that this is like the last state. We're gonna like firm this up, and that way you don't have to like, you kind of prevent long range attacks in proof of stake.
So the 21 days was just for the proof of stake of Celestia itself. It's not, because I know there's also like, I'm like, couldn't you also do like 7 days for optimistic rollups, and then after it doesn't really matter, but the 14 is for the bonding period?
Yeah, you could. I think that, and it's also sort of like, if you want to make sure that it's just easy for people to get the data that they need, it's just nice to have it, on every full node. That makes it more accessible. But, and so it could be good just to have like a similar threshold of like 21 days, just because maybe that's like the subjectivity window that these rollups are comfortable with, for example.
Okay, so I think it's time to wrap it up. That was great. Anything you want to say? Anything you want to plug? Additional research or homework? Anything like that?
I would just say to
questions?
people out there should get into the Celestia Research Forum. There's some really cool stuff happening there, from everything from the ZK account stuff and very technical ideas around improving the Celestia protocol and the future of modularity, to things like Mustafa just recently published this manifesto about like what are modular blockchains and sovereign chains all about, that I think are very inspiring. It's just a really great place where there's a lot of interesting ideas and people engaging. And so I think the audience to this podcast is probably very technical and very deep, and crypto native, and values what we're trying to build. And blockchains are a social technology. If you're into that kind of stuff, you should go to the Celestia forum and get involved and get engaged. And obviously there's the common stuff like Twitter, Celestia.org on Twitter. And last but not least, modularity is about building whatever. It's about people. It's about breaking down the constraints of the infrastructure layer to enable people to build things that were not possible before, by, removing the constraints on scalability and the cost of block space, to removing the constraints on having to build as a smart contract for your application, like being able to build your own application specific chain that is a roll up that you can just deploy in a click. These are the kinds of things that are really exciting, and to me are going to push the next boundary of what blockchains and Web3 are about. And so, if you are a builder and you want to build something really cool and frankly figure out what some of the new killer applications are that are going to be enabled by modularity, this is your moment. Like there's never been a time like right now to get your hands dirty and build an experiment. It's similar to when Ethereum came out and we had smart contracts for the first time. People built the first DeFi applications, NFTs, all these cool things that had never existed before. And I think we're in a similar moment. So it's like time to take advantage of that, be creative, and think about like what's possible now that wasn't possible before.
I've also heard that like the Celestia Research Forum is like giving ETH Research Forum vibes. And then also I didn't know this, but like wasn't the idea of shared sequencers like just appeared right there?
It did. So one of our other Giga Chads that I deeply respect is named Evan Forbes, also known as ZK Fart on Twitter. And he published this, I'm trying to think, it's called lazy sequencing or something like that. Basically is like he invented the idea of like a shared sequencer, as far as I know, essentially. And it was just like, I remember I read that and I was like, I had a forum post kind of about like trying to solve this problem that didn't like, it's kind of interesting, but like it was about using interchain security and stuff like that. And then when I read his, I was just like, yes, this is exactly the idea that everyone's been looking for. And it's just like so genius. So yeah, there's a lot of alpha, I would say, on the forum.
Like 2 years ago? That was like 2 years ago, right?
I think it was December 2022. Yeah. So like a year and a half ago. Yeah.
Crazy. Anyways, thank you so much for watching, and then I'm gonna wrap it up. Bye-bye.
Sounds good.